Hello everyone. In this video we are going to graph the profit maximization of a monopolist, and we're going to do that using a table of data. So we're going to represent what's going on in this table of data of costs and revenues and profits for a monopolist firm, so we can illustrate how we could show profit maximization for a monopolist in a more general form. Let's say we didn't have data in a table. How could we sketch out what it looks like to be a profit maximizing monopolist in just kind of a very symbolic way? So let's look at this data. First, let's look at our average total cost curve. If you'll notice here that it starts pretty high and then gets smaller and smaller and smaller. Then hits 40. That's our bottom there, right? Let's just keep track of that bottom. So $40 is our smallest average total cost, and then it starts to creep up again. So if we wanted to sketch that, it would look like this. So average total cost. And that 40, that seems to happen at a quantity of 10. Right? So we'll put that there. And notice now this is roughly, it's hard to see here, it's maybe not exact, but it's roughly where the marginal cost curve is also, for 10, is also roughly $40. So it turns out that that bottom is probably, somewhere in between here. So it's maybe not quite exact, but we'll stick to whole numbers just to keep it easy. But we've got this price, this demand curve here for various quantities. So let's sketch that out. I'll just use a different color pen too to make it obvious. So that's our monopolist demand curve. Now let's use a different color for their marginal revenue curve. So we're just going to sketch that out there. And let's look for the profit, maximizing quantity. So the highest possible profit here looks to be $70. Well, it's kind of a coincidence that it happens to also be at $10. But let's look for our profit maximizing rule. Does marginal revenue equal marginal cost? Sure enough, it does. So this turns out right here to be the profit maximizing quantity. I want to make a quick note. It's the profit maximizing quantity, not because it's the intersection of marginal cost and average total cost. It just happens to fall there. But this is the quantity where our marginal cost curve and our marginal revenue curve are intersecting right there. So it's the quantity where marginal cost is equal to marginal revenue. Now, here's where it gets a little bit more interesting for a monopolist. Remember we said that a monopolist can choose their price. Well, you might be saying, well, we didn't choose our price here, we actually chose our quantity, but by choosing your quantity, you're also choosing a price. And notice that this price is not the marginal cost, right? It is not the marginal revenue either. This price that they can charge is a lot higher than what it costs them to produce, right? So our price is higher than that marginal cost. So we can go up, in fact, we go up on this curve to the demand curve and see that they are able to charge so where that intersects is actually a little bit lower, right? 38. So where those intersect, the price is $47. So we can see in general, we have the same process of finding the profit maximizing point for a perfectly competitive firm, but with one tweak. With a perfectly competitive firm, we just had to take that price as given. For a monopoly, we find the point where marginal revenue and marginal costs intersect, and we go up to the demand curve. They don't charge $38 because people are willing and able to pay more, so that's what they're going to do. They're going to end up paying more. So You go up to the demand curve for that quantity, and that gives you the price to charge. So let's take a look at what that might look like more generally if we didn't know what those numbers are. So quantity, dollars, our average total cost curve, and our marginal cost curve. We'll have a blue demand curve and a marginal revenue curve that's got roughly twice the slope. So remember our first step, find where the marginal cost and marginal revenue curves are equal to each other. In other words, where they intersect. So our point where they intersect is right there. So that's our marginal revenue curve, our marginal cost curve. Go down here, and that gives me my profit maximizing quantity. Second step, find the price that they will charge. So I go up, keep going up from that intersection point up to the demand curve, and this gives me my monopolist's price. My next step, find out if they're making a profit. Are they making a profit? Well, at that price, is that price higher than the average total cost? So that's my average total cost. My average total cost for this profit maximizing quantity. I can find that just by going up to my average total cost curve. So price is greater than average total cost, so yeah, that is my profit. I find that in the exact same way I would find the profit for a perfectly competitive firm. Now, one different thing here is find the markup. So markup is defined as a price greater than marginal cost. So I know what my price is, I need to find what my marginal cost is. And I find that just by going up from my quantity up to my marginal cost curve. So I'm on my marginal cost curve. This tells me the marginal cost of that quantity. So this is the amount that I am able to mark up this good because I'm a monopolist. Now, let's evaluate what this means in terms for some market outcomes. Now, recall with perfect competition, in the long run, in the short run actually, there was a possibility of profit, but the firm was producing at least an allocatively efficient quantity. Maybe they weren't producing a cost-efficient quantity, they weren't producing at efficient scale, but they were at least producing an allocative efficient quantity because there was no deadweight loss. Well, let's see if that's true here. Let me make this a little bit smaller so we can take some notes. Right, so let's see. Are they producing a profit? So let's say this is the short run. Are they producing a profit in the short run? Well, price is greater than average total cost, right? So yes, they do produce a profit in the short run. Are they cost efficient? Or in other words, are they producing an efficient scale in the short run? And the answer to that is no, right? So this point here would be the efficient scale for this firm, but that is not what they are producing, right? That's not, if they're not producing that quantity, so they are not producing efficient scale. And in general, that's the case, right? With rare exceptions, you might just happen to fall on that quantity like we did in our first example, but that's pretty unusual. But we're not too worried about that, right? So far, we don't have any difference between perfect competition in the short run. They produced a profit in the short run or a loss. They didn't produce the efficient scale in the short run. Let's think about allocatively efficient then. Are they allocatively efficient? And in order to do that, we have to figure out if there is any deadweight loss. So is it true that our demand curve and supply curve, are we producing the quantity where those two things intersect? No. Right? They are not producing that quantity. That means here's that familiar deadweight loss triangle. Now let's stay with tradition. Deadweight loss is black because it's like being lost into a black hole. This is the efficiency loss from a monopoly. So they are not allocatively efficient in the short run. Well, let's think about this. Okay, maybe that's some bad news. This is maybe why we don't think monopolies are such a great thing, because they're not very efficient and they earn economic rents, but maybe it'll fix itself in the long run, right? So what about the long run? Well, the long run means firms enter and exit until there's no incentive to do that. One slight problem: we have no ability to enter or exit because of barriers to entry. That's what made it a monopoly in the first place. So there is no long run. The short run and the long run are actually the same thing. So this is the permanent situation. You have economic rents, you have producing not an efficient scale, and you have deadweight loss.